Hello and welcome to the Weekly AI Yap, where I'll be going through this week's AI news, talking about it, giving my thoughts, and having a good time for roughly 20 to 30 minutes. So this week there actually wasn't that much open AI news, so thankfully I don't have to talk about them much. However, I will be talking about them in context in relation to Janus from DeepSeek, right? So DeepSeek released a new model. It's a 1.3 billion parameter model, and it's an early fusion model, right? So similar to Meta's Chameleon, or what OpenAI probably did with GPT-4o, or what Gemini probably did with Gemini, not with what Google probably did with Gemini. It's an early fusion model where you give it either an image or text as input, and you can get either image or text output, right? And so obviously 4o and Gemini are different because those models have more modalities, right? So Gemini can take in like audio, it can take in video, it can take in image, it can take in text, it can take in like all of these different modalities. GPT-4 is very similar. It can take in audio, image, text, probably video, and it can also output those modalities. The open source mixed modality models are all image and text only. So Chameleon is image and text in, image and text out. Though when they actually released it, they got rid of the image out in the fine-tuning process because Meta is allergic to image generation models that are being released. And what DeepSeek released for Janus, what Janus is it's also a mixed modality model, like image and text in, image and text out. And so these models are actually really cool because what they allow you to do is effectively have much better image recognition capabilities, and theoretically lets you do image editing via text in like a chat interface, right? So you like upload an image and you can like get to like edit the image and do all types of funky stuff, right? And so, and they can do also a lot more, right? You can have them as just like a raw image generator because they're going to understand text way better than any like clip style text stuff. You can have them as a sort of like blog post understander, because if you have like a blog post with some text and image and text and image, you can have it like understand that like really well. And so like they will understand all of that really well. You can have it generate that stuff, right? Because back when Meta announced Chameleon, what they showed is like they one of the researchers asked the prompt like, "Hey, can you? I'm bored. Give me some cool pictures of birds, right?" And then what Chameleon did is Chameleon responded with a picture of like a toucan, and it's like, "Hey, this is a toucan. Here's some information about a toucan." Then another picture of a bird. Here's some more information, and it was able to interleave text and images in its output, right? So you're able to have natively interleave text and images, and this could be really useful in a whole bunch of different places, right? Because the thing about these models is not really how good are they as they are, it's what are they able to unlock when compared to before, right? And with Janus being a really small model that is capable of this, Janus is able to unlock a whole bunch of capabilities that we weren't having, like for example, on-device like recognition, right? Like imagine you have like an HTML blog post on your device, and you're trying to understand, hey, what is this guy actually trying to say? For what you tried to do previously is the images and text weren't interleaved; they'd be separate, and Transformer kind of has to understand difference. Now what you're able to do is just on your phone, theoretically, you'd be able to like look at a blog post, be like, hey, can you like summarize and explain this for me? And then the LLM, so Janus in this case, would go. It like look through the blog post and be like, oh yes, or like the HTML file, like the rendered HTML, and be like, hey, this like article talks about like X, Y, and Z. It like summarizes for you, and it'd be like really nice and helpful, right? Like it would allow for a whole bunch of new stuff that wasn't possible before, right? And so, especially with image and whatnot, when somebody in open source makes like a combo image, text, and audio in and out, like early fusion, image, text, and audio, what you effectively have is a very easy way to make that like really old like 4.0 demo, right? Because when OpenAI was on stage, they had like the 4.0 demo where they had the phone, and it was like they'd have it like look at their face and it's like, hey, can you tell me about me? Or like, and it had like look at the word and whatnot, and so you could have like multimodal in, multimodal out, really cool stuff, right? And so when somebody in open source does that, you can do that too. You can just straight up build that, right? And so because we have image, like text and image in, text and image out, what we're also able to do right now is effectively build that demo as well, though much easier now, whereas previously you need multiple models, right? And so the good thing here is that this one's actually released by DeepSeek. And so DeepSeek is actually in a really interesting situation, right? Because DeepSeek, what they had to, so they used to be a quantitative finance trading firm, right? So they had all the best developers, and they'd like use it to like beat the markets with like trading to like make the most money, right? When the Chinese government or the CCP told them, hey, you guys can't just be doing this. You have to do something actually useful to society, otherwise we will shut you down, right? Because the Chinese government is very heavy-handed like that. The DeepSeek, they were kind of forced to be like, oh, we have a lot of GPUs, we have some of the smartest engineers. What can we get them to do to prevent us from being shut down? And it's like useful. So they're making AI models and they're doing it in open source, right? So the Chinese government, it looks like they've been like slightly satiated, and so DeepSeek, they're just have to do AI models. But in order to like make sure they don't get under the eye of the CCP, they have to do it all in open source. They have to open source their research. They're going to have to open source their models and all of that, right? And so DeepSeek, doing this research, they released it, and now it's in the open like space, right? So anybody can use this research. And I think that's the kind of cool thing about a ton of these Chinese AI creators, which is that they are kind of forced to do it in the open source. They're going to do it in the open source. And so now, everybody from everywhere in the world can just use the models. They can learn from the models. They can build on top of these models, right? And so now you just have like an incredibly like cool way of just like, you know, having new models come out that are all really good, right? Like DeepSeek Coder is arguably up there with Claude 3.5 Sonnet in terms of specifically code knowledge. Obviously, Claude is, I'd argue, better, but the fact it's open source and it costs like what, 48 cents per million tokens, like it's insanely cheap. And it's really good code, and it has like a pretty big context window. Like DeepSeek makes very good models, and they do it for cheap because, again, they kind of have to, otherwise the CCP is like, you're trying to make a ton of money from this, and like they're not super into that. And so you have these really open source models that are dirt cheap. And then like if you compare them to like Meta, right? Meta, they kind of want to keep some stuff out because they don't want to get like sued or any of that, right? Like Mark Zuckerberg's dealt with enough like public scrutiny on Meta, right? And so like they've dealt with enough public scrutiny. They're just releasing the models purely so that if people make them better, it's better, right? And like the entire open source ecosystem is kind of stabilized on top of the Llama architecture, right? Like they've kind of stabilized. It's like if your model doesn't fit the Llama architecture, it's not really going to work with Llama.cpp, which is the largest like inference platform. So it's not going to really work with Ollama, which I guess Ollama doesn't really run on Llama.cpp anymore. They're on their own thing, but like it's not really going to work there. It's not going to, right? Like there's just a whole bunch of issues if you don't follow like the Llama architecture. And obviously when Llama 4 comes out with a different architecture, people are going to adapt. But like Meta releases these models so that when they do inference, it's cheaper for them, right? Because now what they're able to do is they're able to use Llama.cpp in the inference stack, and it's like much cheaper and more optimized because now you have the entire way of the world behind you. Google, they only release stuff when they're like, this is not useful research. Let's just release it so it looks good, right? Like Google releases research for a PR stunt. Meta releases research because they just, they wanted to lower their costs. And then DeepSeek releases research because if they don't, they die, right? Like releasing research is like a matter of like survival for them, right? And then I should probably go through a bunch of other people. Like OpenAI releases research, they don't really release research anymore. They've shut up, right? Anthropic releases research for AI safety reasons, right? Because Anthropic is really big in the AI safety, right? Because like when you look at like Claude 2 was kind of lobotomized due to safety, right? Like Alibaba releases their research because they're kind of doing this to look good to the Chinese government, to like, you know, have it all be good. Because Jack Ma was effectively kicked out of China because Alibaba was making too much money, right? Like Alibaba's also a little bit in that like survival race with DeepSeek. Then you have, I get Cohere. Cohere releases research because they make an enterprise product, so enterprises are going to pay them money instead of like, you know, billing on top of that, right? Like a bunch of these companies, they release research because they have legitimate reasons for it. And I think like they could all stop at any time, right? Like Meta could stop releasing research at like any time they wanted. They're like, oh, this is too close to AGI. We're going to get into so much like PR trouble. Let's like stop releasing. I don't think they will. I think Meta will continue releasing research a lot, but you know, it's not like Meta will stop existing the moment they stop releasing the research. DeepSeek will stop existing the moment they stop releasing the research. And so we know for a fact they will release their research. And so we can kind of ride the DeepSeek train, right? Like Janus is a model that you can just like build on top of, right? Like if you build your apps on top of Janus, you know the model, the next iteration of Janus will be open source, right? Like it's not going to be like a GPT-2 to GPT-3 situation where the model went from open source to not, right? Like you know that the next Janus is open source and you can build on top of that, right? Like, you know all of that stuff. And so now you have the situation where it's like when you're picking your models, right? Like you're an application developer, you're picking your models, and let's assume you want to use these early fusion models, and let's assume a bunch of them come out in the next little bit, right? Like you're gonna have a DeepSeek model, you already have the Meta Chameleon that will hopefully be better, then hopefully Quen will get in here and like all that stuff, right? You have all of these early fusion models, and you're trying to pick, right? Now you have the ability to pick between companies, and you can also pick models not just based on how open they are or whatnot. You can pick these models based on how much you trust the company to release their improvements, right? And so you can effectively be like, hey, we're going to release all of our improvements, we're going to do all of that, and it's great. Now I should probably move on to the next stuff. You also had Mistral. They released 2 new models, the Ministral models, right? So you have Ministral 3B and Ministral 8B. Now I think these models are actually kind of stupid, right? Mainly because of licensing, entirely because of licensing. Ministral 3B looks really, really good, right? It's like, I believe it's like about as good as like Quen 2.5, 2.5B. I think it's like a little bit better, right? But like the problem is the 3B, you can't download the weights. It's only accessible via API. And the entire point of a 3B model is to run it on embedded devices. So I don't actually understand what was going on there, because they're just like, hey, let's like only offer Ministral 3B on API, but then let people download the weights to the 8B. Like that just, in my head, it doesn't make sense, right? Like that just doesn't really make sense to me. Like I kind of would have understood like, oh, let's make the 8B, let's make those weights like API only. And then the 3B, let's let the people download the weights. But I guess the 3B is more embeddable, so they're like, hey, if you want to embed it, get a commercial license, right? Though in that case, I think people are just going to use Llama 3.2 3B and then like be done with it, right? Or even Quen 2.5.5B. The point, like the fact we can get LLMs working in such like in like a 0.5B that are like very good, right? Because Quen 2.5.5B is probably about as good as like Llama 2.8B. Right? Like, that might be a little bit, I think it's probably, based on my testing, it's probably about at that level. Maybe like a hypothetical, like a Llama 2 7B. But like, I guess it's as good as like a hypothetical Llama 2 like 5B, where it's not entirely at that level, but it's massive efficiency gains. Because all of the knowledge we're learning about like these models and how to train them better and how to optimize them better and how to distill them better and all of that, right? We're able to like make smaller and smaller models. And so, right, like even if you look, right, like Llama 3.2 is just, let's just distill Llama 3.1 models, like 3.1, 8B, and 70B into the 3 and into the 1 and 3B, right? But then you have Llama 3.1. And Llama 3.1 is, let's just take Llama 3, 4, 5B. Of course, they delayed Llama 3, 4, 5B into 3.1, 4, 5B, because remember, the 4 or 5 wasn't released with Llama 3, it was released with Llama 3.1, but that was the actual training job. Then they distilled that model into the 8B and the 70B, because distillation is actually a very cool technique. And so they're just effectively distilling these large models into really small models that you can now embed, right? And so after the 2 rounds of distillation, you get like Llama 3.2, 1, and 3B, and now you're able to just embed these models in places. Like you can just be like, hey, I'm going to take Llama 3.2, 1B, and I'm going to put it in my app, or I'm going to put it in like my embedded like device. Like imagine, right? Like imagine like a toy for kids, right? And it's running, and so you have like an actual toy, and then you can have it like talk to the user and whatnot, and just you have like a microphone, and then you have like audio out, and you have like a text-to-speech model plus like a speech-to-text model and a tiny LLM, right? Now you can just have like, because you don't really need the most like intelligent thing to put in like a kid's toy, but now you can actually just put that in a kid's toy, and you can like, you know, have it be battery-based and all of that, and have them like plug in or like swap the batteries out and whatever. And because these models are so small, you can run inference on these stuff pretty quickly. And so what you're able to do is you're just able to be like, hey, let me like listen to what the user says. So like maybe like they press a button on the toy, they like say like, hello toy, how are you doing today? And the toy will respond with, I'm good, how are you? So we'll like go into the speech to text model, then the speech to text, then the text output will go into the really tiny LLM, which will then go into a text to speech model, and then you will output that, right? And so these really small models have a ton of room to just kind of be really cool. And what this also allows you to do is effectively build like massive like swarms of like agents and whatnot, right? Like agents, I think, work better when you're able to customize the size of the agent given like what they're trying to do, right? So imagine you have an agent that all it does is take a bunch of text, like summarize it down, you're good to go. Then you probably want a really small model, right? But then if you're trying to do like insights on text, you probably want a bigger model. What you probably don't want is the bigger model to bring it down and the small model to actually do next steps and whatnot. And so what you're able to do is the small models act as really good. Like, here's a bunch of text, summarize it down for me. Here's a bunch of here's a bunch of text like translated into a different format. Like, they're able to do those like not very intelligent tasks, but they're able to do it very quickly. And so they work in a nice composite with a bunch of other models and whatnot. And so, given all that context, like Ministrel 3B being API only, like it kind of makes sense for like the ensemble type stuff, but like you can't embed it anyway. You can't run it on embedded devices, and so it's just kind of like a very strange way to do things. And I think the last thing I'm going to talk about is F5 TTS, right? And so F5 TTS is an open source text-to-speech model. It's like 300-ish million parameters. It's a very small model. And so you can run this anywhere. You basically what you do is you give it like a small bit of like reference speech, and it will like, and you give it some text, and it will like output the text output for you. And so if you go back to like that kid's toy example, if you take like Qwen 2.5.5b, right, so a really tiny model, then you combine it with this, you have 800 million parameters, and assume you're 8-bit quantizing because you don't actually care that much. Right? Though I don't know how much F5 TTS likes quantization. But anyways, so that's 800 megabytes of storage. You can put that on one SD card. And then let's assume you have a speech to text model. Those are usually smaller. Those are usually way smaller. And let's assume that's 200 million. You're going very nice speech to text. Like you just have like a whisper on there. That's 1 gigabyte. You can put that on like a tiny flash chip nowadays. And it'll be like very, very, very cheap. Because that's 1 gigabyte of storage. You put that in there, when you're running inference, you don't actually need that much processing power. You can probably put in like an RP, I guess it's not 2040. I guess you could put it 2040, but 2040 isn't that good. You could probably put in like RP 2350. Just have a few, like have one of those there for like inference. And you have like a pretty good children's toy. And the 2350 is like what, like $2? And then the storage is probably like throwing another $2 for like the connectors and adapters and stuff. And that's like $4 of cost. You can fit that very nicely into like a $30 toy. And it's be like, it just works, you know? Like, you have like you can just have like a smart toy for like $30 that's like all of this stuff going through. And you effectively, like, this text-to-speech gives you a whole bunch of opportunities in like the embedded space, right? And so now you can embed text-to-speech in a bunch of places. You can use the text-to-speech just normally, right? Because it's a very good text-to-speech. Like, obviously, it's no 11 labs. Like, don't get me wrong. This is not an 11 labs TTS. This is, however, a very good open, very small TTS, right? And so now what you're able to, and so what you're able to do now is you can run this TTS on your laptop, and you can effectively like make audio like fully off the grid, right? And so, like, obviously there's a whole bunch of risks that come with text-to-speech, right? Like, oh, what if somebody does text-to-speech like simulation on like a politician, and then they like release this audio? It's like, oh, here's some leaked audio from the politician. Oh no, right? And it's like there's a bunch of risks that come with that. Obviously, I don't think, like, obviously there's like the two types of AI risk, right? So you have the AI existential risk of like, oh, AI is going to take over humanity and all of that, and then you have the like more mundane AI risks of like, hey, people are going to like do deep fakes of politicians doing stuff, and then it's going to like look really bad on a politician and it could like influence elections, right? Like, that's the more, obviously it's not a mundane risk, that's a very big risk. But like, I'm of the opinion that the X risk is too far in the future to actually care about, and the mundane risk, I'm calling it mundane risk. It's the realistic risk, I'm gonna call it. The realistic risk is like real, and you kind of have to figure it out. And so obviously, releasing text-to-speech models does kind of fall in that like real risk like region. However, I think a ton of the stuff we do nowadays, it's like, obviously none of us are ready for like floods of politician deepfakes and whatnot. But like this election, right? Like the US 2024 election, there hasn't actually been that much deepfaking going on, right? Or like the platforms have stopped it and whatnot. Right? Like, I think, like, obviously by later elections it's going to get worse and worse. But like, I think people's general deepfake like senses are like pretty good at this point, and the models aren't good enough yet. Maybe give it another 2 to 4 years, maybe it's a lot worse. But that's what we have to see. We build the defenses as time goes on. Like, a ton of this space, right, is you build a new, better model that could push us closer to like AGI or whatever, or it's just a new capability so that you can build applications on top of it. But then now, sometimes it causes some risk. So some people build like defenses to the risk. And so it's effectively like a constant arms race of like, hey, and it's not really an arms race because the bad actors aren't really training their own models, right? Like if like the Russian like disinformation machine is trying to be like, hey, we're going to try to influence the U.S. election to make sure some X candidate wins, like they're not training custom models here. They're using these models that already exist, these open source models, and maybe they might do some jailbreaking on stuff or whatever. But they're using these open source models, and it's like, okay, we know the capabilities of the open source models. The open source model developers know the capabilities of the open source models. And so when the Russians are trying to figure out how can we use this for disinformation, like a bunch of the social media platforms and a bunch of the people working in AI are trying to figure out, hey, how can we prevent this from being used for disinformation? And like the attackers don't have an edge there like you might have with cybersecurity, where you release a new piece of software, people are obviously trying to fix it, but the threat space isn't so large. Like let's assume like Google releases a new Chrome feature, right? And so now there's they wrote like a massive amount of code. It's like 100,000 lines of code because Chromium is an insanely large project, like 100,000 lines of code. That's a lot of space for there to be vulnerabilities. And so if somebody, cybersecurity, like people find those vulnerabilities first, it's like 50-50 whether those are the attackers or the defenders. Whereas when it comes to model creation and like AI, the like risk is less so, because like the risk here is like, oh, people have to find the solutions to these problems, but like we kind of already are, you know, like the solutions to a ton of this deepfaking problem or whatnot are like already there. Like people kind of knew Trump was sharing deepfakes of Taylor Swift when she did on Twitter when, you know, Grok 2 plus like BFL like Flux was released. And so it's like we have the defense, we have all of that. And it's like the models come out and we had to like kind of prepare for them, but it's like we are preparing. You know, that's just stuff we're doing. And on that hopeful note, I will leave this podcast here. Thanks for listening. Please like and subscribe, and I will see you guys in the next one. Goodbye.